Have you ever wondered what secrets Mars holds beneath its dusty surface? We've gathered the most incredible, lesser-known images straight from NASA's rovers and orbiters. These snapshots reveal breathtaking vistas and hidden wonders of the red planet that you absolutely can't miss. From epic landscapes to mysterious rock formations, let's explore Mars together. This breathtaking composite image was captured by NASA's Curiosity Mars rover on April 8, 2023, showcasing the Marker Band Valley. On the left, we see the valley bathed in a warm golden hue, representing the Martian sunrise or sunset. This warm glow highlights the rocky terrain and the intricate formations. As we move to the right, the scene transitions into a cool, blue tone, depicting the Martian day. The contrast between the lighting effects reveals the dynamic atmosphere and the diverse geology of Mars. Look closely, and you'll notice the uneven terrain, various formations, and even the rover's tracks on the ground. The Curiosity rover, partially visible in the lower right corner, plays a crucial role in exploring and studying these fascinating Martian landscapes. This image offers a detailed and dynamic view of Mars, highlighting how the lighting and atmosphere change throughout the day. It's a visual journey through the Martian day, brought to you by NASA's Curiosity rover. Here's one that was captured by the HiRISE camera aboard the Mars Reconnaissance Orbiter. It looks like a bear's face on the Martian surface. Notice the two craters that create the eyes, giving the impression of a bear gazing back at us from the red planet. A circular fracture outlines the face, giving it that distinct bear-like contour we can clearly see. And finally, a V-shaped collapse structure forms the nose. It's amazing how natural formations can create such recognizable shapes. This intriguing formation is located in the Olympus Terra region of Mars, a heavily cratered highland area that offers a glimpse into the planet's ancient past. The Martian surface never ceases to surprise us with its intriguing formations and mysterious landscapes. Check out this captivating rock discovered by Curiosity in Becquerel Crater. This tiny rock, smaller than a penny, looks just like a flower or a piece of coral. These intricate, branch-like protrusions are not just visually stunning, they tell a fascinating story. This rock formation was created billions of years ago when minerals carried by water cemented the rock. This discovery adds to our evidence of past water activity on Mars. Although Mars isn't geologically active like Earth, its surface features have been heavily shaped by wind. Check out these incredible wind-carved formations known as yardangs. These elongated ridges, formed by persistent wind erosion, are common on Mars. The wind also creates ripples and small dunes on the sandy surface. In Mars' thin atmosphere, light isn't scattered much, making the shadows cast by the yardangs sharp and dark. This gives us a clear view of the intricate details of these formations. This dark mound, known as Irison Hill, is located on the Murray Formation on Lower Mount Sharp. This intriguing feature was also captured by Curiosity. Irison Hill stands out with its dark rocks and boulders of varying sizes, scattered across the slope, contrasting with the lighter-colored, layered rock formations in the foreground. Nearby, Curiosity examined a linear sand dune in February 2017, providing valuable insights into Mars's geological and atmospheric processes. The terrain around Irison Hill offers a window into Mars' complex geological history and surface composition. Each rock and feature tells a story of the planet's dynamic past. This striking image, captured by the Mars Reconnaissance Orbiter in 2010, showcases a fascinating phenomenon on the Martian surface. At the center, you can see a towering dust column, known as a dust tower. These concentrated columns of dust rise high into the Martian atmosphere, often during dust storms, reaching heights up to 80 kilometers. Surrounding the dust tower, we have blue and white clouds composed of water vapor. These clouds are similar to those we see on Earth, providing valuable insights into Martian weather patterns and atmospheric conditions. Mars may not be geologically active like Earth, but its weather can be equally dynamic. Dust towers like these contribute to the planet's unique climate and help scientists understand the complexities of Martian weather. Notice anything familiar here? Captured by the Mars Reconnaissance Orbiter, this image shows the results of cooled lava preserving a footprint of where dunes once moved across Mars. This preserved dune has an uncanny resemblance to the Star Trek symbol, a perfect blend of science and pop culture. This formation is a result of natural processes. The texture of the surface shows both rough and smooth areas, indicating different geological activities at play. It's a prime example of how Mars' landscape is shaped by its dynamic environment. Cooled lava flows have helped preserve this unique feature, offering scientists valuable insights into the planet's geological history and the role wind plays in shaping its surface. This composite image from Curiosity was taken in September 2015, looking toward the higher regions of Mount Sharp. In the foreground, we see a long ridge teeming with hematite. Hematite is an iron oxide mineral that often forms in water, hinting at Mars' watery past. Just beyond the ridge lies an undulating plain rich in clay minerals. These minerals are key indicators of past water activity, as they typically form in wet environments. And further back, we see a multitude of rounded buttes, all high in sulfate minerals. These sulfates likely formed in acidic, water-rich environments, adding another layer to Mars's complex history. The changing mineralogy in these layers suggests a shifting environment on early Mars, but all these minerals indicate exposure to water billions of years ago. This landscape tells a story of a planet that was once much more dynamic and possibly habitable. Lastly, what you're seeing here is precipitated water ice covering the terrain, a phenomenon observed by the Viking 2 lander. The water ice has precipitated by adhering to dry ice, creating a unique layer on the Martian surface. This fascinating process gives us a glimpse into the dynamic interactions between water and carbon dioxide on Mars. Utopia Planitia is a vast region on Mars, known for its intriguing geological features and history. The presence of water ice here is a significant finding, offering clues about the planet's climate and potential for past or present life. The Viking 2 lander, part of NASA's Viking program, was instrumental in capturing this image and providing valuable data on Mars's surface and atmosphere. Launched in 1975, the lander has contributed greatly to our understanding of the red planet. That's all for this one. Did any of these blow your mind? What else would you like to see in future videos? Thanks for watching, and if you enjoyed this video, give it a thumbs up. Captured by the European Space Agency's Mars Express mission, this stunning 2018 image showcases the Korolev Crater. Spanning more than 50 miles across, this magnificent crater is filled with water ice, and it's located near the North Pole of Mars. The Korolev Crater is like a natural ice chest, preserving water ice under Martian conditions. The crater's unique topography creates a cold trap that keeps the ice stable and prevents it from sublimating, even under Mars's thin atmosphere. The water ice in Korolev Crater offers valuable insights into Mars's climate and potential water resources. Understanding these ice reserves is crucial for future missions and the possibility of sustaining human presence on Mars. Launched in 2003, the Mars Express mission has been a trailblazer in exploring Mars, providing high-resolution images and vital data about the planet's surface, atmosphere, and subsurface. The discovery of the ice-filled Korolev Crater is just one of its many contributions. This striking image, taken by the HiRISE camera on NASA's Mars Reconnaissance Orbiter, showcases the rugged terrain of Cerberus. Cerberus fossae are a series of semi-parallel fissures on Mars, formed by faults in the region which is known for its significant tectonic activity. The two largest quakes detected by NASA's InSight mission originated here, making it a hotbed of Martian seismic activity. Scientists have also observed signs of tectonic activity, such as landslides, further highlighting the dynamic nature of this region. The lighter sandy upper section contrasts sharply with the darker bluish lower section. This color variation indicates different materials or geological processes at work. This is the first photograph ever taken from the surface of Mars. Captured on July 20th, 1976 by NASA's Viking 1 lander, this iconic image marked a monumental achievement in space exploration. The image reveals a rugged and rocky landscape, with various sized rocks scattered across an uneven, dusty surface. This was humanity's first close-up view of the Martian terrain. In the lower right corner, you can see part of the Viking 1 lander. This pioneering spacecraft provided crucial data and images that paved the way for future Mars missions. The Viking 1 mission was part of NASA's Viking program, which aimed to study Mars's surface and atmosphere. This first photograph symbolizes our relentless quest for knowledge and exploration beyond our planet. Another one from HiRISE, taken in November 2013. Dominating the scene is a fresh impact crater, spanning approximately 100 feet in diameter. This crater is surrounded by a large rayed blast zone, evidence of the powerful impact that created it. The fresh crater appears blue in the enhanced color of the image. Because the terrain where the crater formed is dusty, the impact removed the reddish dust in that area, revealing the blue tones beneath. This color contrast highlights the dramatic change caused by the impact event. These fresh impact features provide scientists with valuable insights into Mars' geological processes and surface conditions. Each new crater tells a story of the dynamic environment on the red planet. This stunning image was captured by, you guessed it, HiRISE. This was taken in June 2014, and it shows a kilometer-sized crater in the southern hemisphere of Mars. Check out the frost on all its south-facing slopes. This frost appears as a white or light-colored area, standing out against the darker, reddish terrain. This frost forms in late winter as Mars transitions into spring. The presence of frost highlights the seasonal changes on Mars and the dynamic interactions within its atmosphere. The frost observed in this crater is likely composed of water ice, providing valuable insights into the distribution of water on Mars and its climate patterns. Understanding these features is crucial for future exploration and potential human missions. This is the famous Face on Mars, located in the Cydonia region of the Red Planet. Captured by NASA's Viking 1 orbiter in 1976, this formation has sparked decades of fascination and speculation. The feature resembles a human face, complete with eyes, a nose, and a mouth. But what causes this uncanny likeness? This phenomenon is known as pareidolia, where our brains recognize familiar patterns like faces in random objects. The face on Mars is a perfect example of this effect, created by the play of shadows and light on the Martian surface. Later missions, including the Mars Global Surveyor and the Mars Reconnaissance Orbiter, provided higher resolution images, revealing that the face is actually a mesa, an elevated landform shaped by natural processes. That's all for this one. What images intrigued you? Leave a comment below and let us know. Thanks for watching. There's a lot to unpack in this one. This fascinating image from the ESA's Mars Express shows a region known as Austral Scopuli. This area is full of features that emerge with the arrival of spring and the retreat of the ice cap. First, we have the smooth top surface. These smooth surfaces are created by layers of ice and dust that have accumulated over many seasonal cycles. Each layer represents a different season, preserving a record of past climatic conditions on Mars. The smoothness indicates relatively undisturbed deposition, suggesting a calm and stable environment over extended periods. Next, check out the dark fans. These features are formed when dust is blasted out from underground gas pockets. As the gas escapes, it carries dust particles that settle in the direction of the prevailing wind, creating these dark streaks. These fans provide insight into the subsurface composition and the dynamics of Martian winds. The patterned ground features dusty polygons bounded by icy ridges or troughs. These polygonal patterns are created by the freeze-thaw cycles of water ice in the soil, causing the ground to crack and form distinct shapes. These patterns are indicative of permafrost processes and are similar to features seen in Earth's polar regions. You'll also see bright fans. These occur when ice condenses on top of the dark fans made by dust blasted out from underground gas pockets. As temperatures drop, water vapor in the atmosphere sublimates and forms a frost layer on top of the existing dark material, creating a bright reflective surface. And don't miss the exposed layered deposits. These layers of ice and dust have been laid down over many seasonal cycles, much like the smooth surfaces. However, these deposits are exposed as the surface ice retreats, revealing the stratified history of deposition and erosion. Studying these layers helps scientists understand the climatic history of Mars and the processes that have shaped its surface. Australe Scopuli offers a stunning glimpse into the seasonal changes and dynamic processes on Mars. Feast your eyes on this stunning image of Mars's South Pole, captured by the ESA's Mars Express orbiter in 2015. This captivating view reveals a landscape dominated by an expansive ice cap. The icy surface appears layered and textured, indicating the presence of different materials and varying ice compositions. These layers have been laid down over many seasonal cycles, preserving a record of Mars's climatic history. What's truly fascinating is the evidence for liquid water beneath this icy surface. Studies suggest that there could be subsurface lakes of liquid water trapped beneath the ice cap. Liquid water is crucial for the potential for life and for future human exploration. The presence of liquid water beneath the South Pole ice cap could have profound implications for our understanding of Mars's climate history, its ability to support life, and the feasibility of sustaining human presence on the planet. The surrounding regions display a mix of darker and lighter shades of red and brown, hinting at diverse geological formations and various types of soil or rock. This contrast adds to the visual and scientific richness of the Martian landscape. Another one from Mars Express. This one showcases the southern flanks of Olympus Mons, the second tallest volcano on Mars. Olympus Mons rises approximately 11 miles above the surrounding plains, making it one of the most prominent features on the Red Planet. The image reveals a complex network of channels and ridges, likely formed by ancient lava flows, tectonic activity, and erosion. These intricate patterns provide valuable insights into the geological history and volcanic activity of Mars. The varying elevations and rugged terrain highlight the immense scale and power of volcanic processes that have shaped this region. Studying these features helps scientists understand how Mars's volcanic landscape has evolved over millions of years. Olympus Mons is part of the Tharsis volcanic plateau, a region that hosts some of the largest volcanoes in the solar system. Understanding this volcano and its surroundings offers clues about Mars' internal structure and geologic history. Seeing a trend? This one is also from the ESA's Mars Express, and it shows the Syria Planum fracture system, which is located about 1,800 kilometers southwest of the vast Tharsis volcanic region. The ground resolution of this one is approximately 14 meters per pixel. The Syria Planum features are associated with tectonic stresses linked to the volcanic activity of the region. These fractures are evidence of the immense geological forces at work beneath Mars's surface. The fractures were likely formed by tectonic stresses caused by volcanic activity in the nearby Tharsis region, home to some of the largest volcanoes in the solar system. This connection between tectonics and volcanism provides valuable insights into the dynamic processes shaping Mars. This image was captured by the Color and Stereo Surface Imaging System, or CASIS, on board the ExoMars Trace Gas Orbiter mission. It shows a section of Melas Chasma, part of the vast Valles Marineris Canyon system on Mars. Valles Marineris stretches over 4,000 kilometers across the planet's surface and plunges more than 7 kilometers deep in places. The section seen here is about 5 by 6 kilometers in size. This color infrared image combines the near, pan, and blue filters of CASIS, emphasizing the spectral diversity of landforms and sediments on the surface. The image details a blocky deposit on the floor of Melas Chasma, consistent with an eroded and exposed landslide deposit. These blocky features suggest a history of significant geological activity. Wind-blown ripples are abundant and interspersed between the blocks, indicating the influence of Martian winds in shaping the landscape. These ripples provide clues about the atmospheric conditions and wind patterns on Mars. The CRISM spectrometer on NASA's Mars Reconnaissance Orbiter revealed a variety of minerals and phases correlating with the light-toned blocks seen here, including nontronite, jarosite, aluminum-rich clays, hydrated silica, and acid-leached clay. The tan-colored ripples likely contain ferric iron oxides, giving rise to their distinctive color. These minerals tell us about the chemical composition and weathering processes on Mars. There's also evidence of the past presence of water in this region. The bright white layered materials imply the presence of hydrated calcium sulfate, possibly gypsum, which is thought to have formed through the ponding and subsequent evaporation of water that may have once occupied portions of the chasma floor. And the last one is from, you guessed it, the Mars Express. This is Aurori Chaos, a large area of chaotic terrain located in the Margaritifer Terra region on Mars. Aurori Chaos is characterized by a complex and chaotic terrain with a mix of ridges, valleys, and collapsed regions. Its appearance is the result of ancient catastrophic flooding and tectonic forces that shaped the landscape. This image was created using data from the nadir and color channels of the high-resolution stereo camera. The nadir channel provides a direct top-down view, allowing us to see the surface details as if looking straight down from above. Something worth noting: north is oriented to the right. This orientation gives us a clear perspective of the region's geological features. Aurori Chaos is part of the larger Margaritifera Terra region, which is known for its rich geological history. Studying this area helps scientists understand the processes that shaped Mars's surface, including water flow and tectonic activity. That's all for this one. If you liked this, leave a comment below and you know the rest. Thanks for watching and see you in the next one. NASA recently used its powerful high-resolution imaging experiment, more commonly known as the High-Rise camera on board the Mars Reconnaissance Orbiter, to take a breathtaking image of a dust devil traversing Syria Planum on Mars. Dust devils are common on Mars, but did you know their shadows can be used to estimate their height? Some dust devils can reach up to 20 kilometers or 12 miles into the Martian sky. Studying dust devils on Mars is crucial for understanding surface processes on other planets. But with the atmospheric pressure on Mars being only a fraction of Earth's, what processes are responsible for producing these towering dust devils? Dust devils on Mars are similar to those on Earth. They are solar-powered phenomena where the ground heats up, causing air to rise in columns. If the column of air is spinning, it can get narrower and spin faster, forming a dust devil. As long as hot air is available at the bottom, the dust devil can survive. If it moves over colder ground or stops moving, it dissipates. Dusty regions on Mars, with their hot surfaces during the day, are ideal for dust devil formation. Syria Planum isn't the only place on Mars where HiRISE has observed dust devils. Other locations include Amazonas Planitia, southern latitude dune fields, Ganges Chasma, and Nili Fosse. Martian dust devils can reach several kilometers into the sky and are known for leaving tracks and streaks across the Martian surface. These tracks help scientists learn more about both dust devils and dust storms on Mars. Dust devil tracks are more than just fascinating patterns. They provide valuable insights into Martian weather and surface processes. Dust storms can erase old dust devil tracks, allowing new ones to be created, which helps scientists monitor activity from both processes. Dust devils contribute to the baseline level of dust in the Martian atmosphere, which plays a significant role in weather and atmospheric heating. Dust devils also play a practical role in Mars exploration. They can clean dust off the solar panels of spacecraft, as seen during the missions of the Mars exploration rovers, Spirit and Opportunity. Both rovers, initially designed to last only 90 sols, about 92.5 Earth days, far exceeded their expected lifespans, thanks in part to dust devils cleaning their solar panels. More recently, NASA's Perseverance rover captured the sounds of a Martian dust devil in Becquerel Crater, providing another dimension to our understanding of these phenomena. One significant difference between Earth and Mars is their obliquity, or axial tilt. Mars lacks a large moon to stabilize its tilt, leading to dramatic changes over time. These changes can influence Martian climate and dust devil activity. Mars' axial tilt can vary from 15 degrees to 45 degrees, compared to Earth's relatively stable tilt between 22.1 and 24.5 degrees. As Mars' axial tilt changes, so does its climate. High obliquity increases dust devil activity, while lower obliquity may see dust devils becoming the dominant source of atmospheric dust. Understanding these changes is crucial for studying long-term climate patterns on Mars. Dust devils are just one of the many unique features on the red planet. By studying their processes and patterns, scientists continue to learn more about Mars's present, past, and even its future. This incredible image showcases Victoria Crater, about 800 meters or half a mile in diameter. It has been home ground for NASA's Mars Exploration Rover Opportunity for more than 14 out of the rover's first 46 months on Mars. Opportunity first reached the crater's rim on September 27, 2006, during the 951st Martian day, or SOL, of the rover's work in the Meridiani Planum region of Mars. The rover then explored clockwise about 1/4 of the way around the rim, examining the diverse terrain and geological features. After completing the initial exploration, Opportunity returned to a point close to its first overlook. On the mission's 1,293rd sol, or September 13, 2007, Opportunity began a sustained exploration of the crater's interior. The rover entered at an alcove called Duck Bay on the western side of Victoria, marking the beginning of an exciting new phase of its mission. Victoria Crater provided Opportunity with a unique opportunity to study the Martian surface and subsurface. The exposed layers of rock within the crater offered valuable insights into the geological history of Mars. Scientists were able to analyze the composition and stratification of the rocks, uncovering evidence of past water activity and the planet's climatic evolution. The rover's journey through Victoria Crater revealed a landscape marked by rocky outcrops, sand dunes, and diverse mineralogy. Opportunity's detailed imaging and analysis helped scientists understand the processes that have shaped Mars's surface over millions of years. This incredible image was captured by the high-resolution stereo camera on board the Mars Express. It shows a detailed view of the Libya Montes region located in the equatorial region of Mars at the boundary between the southern highlands and northern lowlands. The image was acquired on February 21, 2017, with a ground resolution of about 15 meters per pixel. Libya Montes is a region marked by diverse geological features, including ancient river valleys, impact craters, and rugged terrain. The area is believed to have been shaped by both fluvial and tectonic processes, offering valuable insights into Mars's geological history. Take a closer look at the ancient river valleys, which suggest that water once flowed through this region. These valleys are evidence of Mars' wetter past and the potential for habitable environments. Additionally, the presence of numerous impact craters provides clues about the planet's history of cosmic collisions. The rugged terrain and tectonic features seen here indicate that the region has experienced significant geological activity. These features are a testament to the dynamic forces that have shaped the Martian surface over millions of years. The Libya Montes region also boasts a rich diversity of minerals. The color variations in the image highlight different types of rock and soil, each telling a part of Mars's complex geological story. By studying these minerals, scientists can gain a deeper understanding of the planet's composition and the processes that have influenced its surface. This incredible image showcases the terrain surrounding Mars's North Pole, known as Planum Boreum. The pole itself is covered in layers of fine dust and water ice, stacking several kilometers thick and stretching out for around 1,000 kilometers, approximately the width of France. While most of this material is not visible here, you can see the beginnings of Planum Boreum to the right of the frame. Subtle wrinkling shows where layers of material are starting to build up. The ground has also built up more starkly in steps, most clearly visible in the topographic view of this region below. The lowest altitude regions are blue-green, and the highest are red, white, and brown. These layers, formed as a mix of dust, water ice, and frost, settled on the Martian ground over time. Each layer holds valuable information about Mars's history, telling the story of how the planet's climate has changed over the past few million years. In Martian winter, the layers are topped by a thin cap of dry ice, or carbon dioxide ice, a couple of meters thick. This cap completely disappears into the atmosphere each Martian summer, revealing the intricate layers beneath. Near the center, you can see two steep banks, or escarpments, cutting vertically through the frame. These mark the boundary between the layered deposits that stretch out of frame towards the pole on the right, and the vast, sweeping dune fields covering the lower terrain of Olympus Planum to the left. The layers of material in Planum Boreum offer a fascinating glimpse into Mars' climatic history. The mix of dust, water ice, and frost provides clues about the environmental conditions that have shaped the planet over millions of years. This striking scene in and around Becquerel Crater, the largest crater in this view, reveals the powerful forces of wind and water in Mars's turbulent history. The crater features a mound of light-colored sulfate deposits formed from evaporating water, sitting amid a sea of dark wind-blown deposits. The light-colored sulfate deposits inside the crater tell a story of water's presence on Mars. These deposits formed from evaporating water, providing evidence of the planet's past watery environment. The darker material has been blown towards the south-southwest, seen at the top left of the image, in a wide swath. This material covers tiny craters, with their raised rims protecting the immediate downwind areas from being swept away. This fascinating interplay between wind and the Martian surface gives us insight into the dynamic processes shaping the planet. This image is a mosaic composed of 4 images taken by the high-resolution stereo camera on the ESA's Mars Express, with an average ground resolution of 17 meters per pixel. This high level of detail allows us to explore the intricate features of the Becquerel Crater and its surroundings. The sulfate deposits within Becquerel Crater are particularly significant. Sulfates form in the presence of water and can reveal much about the past environmental conditions on Mars. By studying these deposits, scientists can piece together the planet's climatic history and its potential for habitability. The dark wind-blown deposits highlight the ongoing influence of wind on Mars's surface. The wind shapes the landscape, moving dust and sand across the planet and even carving out new features. The interaction between these deposits and the crater's features provides a snapshot of Mars's active and ever-changing environment. This breathtaking image showcases Olympus Mons, the largest volcano in the solar system, located on Mars. Olympus Mons is a shield volcano, characterized by its broad, gently sloping profile and massive size. The central caldera of Olympus Mons is prominently visible, with several nested craters indicating multiple episodes of volcanic activity. These craters provide valuable insights into the geological history of Mars and the volcanic processes that have shaped its surface. Surrounding the caldera, you can see extensive lava flows and other volcanic features. These flows extend for hundreds of kilometers, highlighting the immense scale of volcanic activity that created Olympus Mons. The smooth, broad slopes are characteristic of shield volcanoes, formed by the eruption of low-viscosity lava that can travel long distances. Olympus Mons stands approximately 22 kilometers, 13.6 miles, high, nearly 3 times the height of Mount Everest, making it a towering giant on the Martian landscape. Its base spans about 600 kilometers, 373 miles in diameter, roughly equivalent to the size of the state of Arizona. This colossal volcano offers a unique window into Mars' geological past and the forces that have shaped its surface. Studying Olympus Mons helps scientists understand the volcanic history of Mars, including the planet's internal structure and thermal evolution. The volcano's massive size and well-preserved features provide clues about the dynamics of Martian volcanism and the processes that have contributed to the planet's formation. This giant is not only a geological wonder, but also a potential target for future exploration. Understanding its formation and activity could shed light on the broader volcanic processes on Mars and help scientists develop strategies for exploring other volcanic regions on the planet. Olympus Mons offers a fascinating glimpse into the volcanic history and geological wonders of Mars. That's all for this one. Thanks for watching, and if you like this, you know the rest.